I'm explaining the pressure volume curve. We have to understand two basic principles here. First is the lungs collapse at all lung volumes. So lungs have a tendency to collapse at all lung volumes. So that is why the entire lung curve is in the positive region of the graph. And in contrast to that, the chest wall has a tendency to expand at all lung volumes. Only at very high lung volumes it collapses. So most of the chest wall curve is located in the negative region. Only at very high lung volumes the curve comes in the positive region. Now, what is the resting equilibrium? So resting equilibrium is that point where the collapsing force of the lungs is equal to the expanding force of the chest wall. And this point is located at the end tidal expiration. So at end tidal expiration, both the forces they are balancing each other. So the pressure in the alveoli is equilibrating with the atmospheric pressure, which we take as 0 centimeter of water. So the alveolar pressure at the resting equilibrium, which is at the end tidal expiration, is 0 centimeter of water. And what is the lung volume at this point? The lung volume at this time is the functional residual capacity. So, okay, so what is intrapleural pressure? So, the lung is collapsing and the chest wall is expanding. Both the forces are acting in the opposite direction. So, that is why the intrapleural pressure is negative. Throughout the respiratory cycle, it is negative. Now, during inspiration, a greater intrapleural pressure, negative pressure, is generated. So it will pull the lung outward. At maximal inspiration, it becomes minus 8 centimeter of water. Okay. So during passive expiration, the chest wall will relax and the respiratory system returns back to its equilibrium position. And at this equilibrium position, which we have seen at the end tidal expiration, there the intrapleural pressure is minus 5 centimeter of water. So what is compliance? So compliance is change in volume per change in pressure, and compliance is the slope of the pressure volume curve. So generally lung compliance is greatest at around functional residual capacity. At very high lung volumes and at very low lung volumes, the compliance decreases. Okay, the compliance is different in inspiration and expiration because of surface tension. So, in for chest wall, see when the lung volume is low, the chest wall compliance is also low, and as the lung volume increases during inspiration, the compliance of the chest wall increases. So the compliance and what is the compliance of the whole respiratory system? It's a combined compliance of lungs and chest.